Okay, rotation example number 3. Here comes a bridge problem. Draw your picture straight across. Uniform bridge means the weight of the bridge acts straight down the center. 20 meters long. Force is 40,000 newtons. Let me get the pen, sorry. Supported by two pillars located 3 meters from each end. So this guy is 3 meters here. This guy here is 3 meters here. A 15,000 newton car is parked 8 meters from one end. So let's put him right here. He's 15,000 newtons. He's 8 meters away from the end. How much force does each pillar exert? What I like to do is like to pick a pillar to be the pivot point right there. Okay, so that means the torque right here is 0. Remember, whenever you got a pillar point, that means it has a force pushing up here and a force pushing up here, because that's like a normal force. Now do the same thing. Clockwise, counterclockwise equals clockwise. Who's doing the counter? This guy here is down. He's clockwise. He's down. He's clockwise, but he's pushing back up. So he's counter. The trick you must remember is find these distances right here. Okay. He's 3 meters in, right? He's also 3 meters in here. This whole thing is 20. So that's 6. How far is he from here to here? That must be 6 meters. Okay? So that means my counterclockwise, that's the pillar, that's the force up right there, is F up. His distance, right, is going to be what? 6. Make sure that's right. 20. No, it's going to be 14, because 20 take away 6 from each end is 14 times distance. Now you have what? F bridge times distance plus F car times distance, because each one of those produces a clockwise torque. Now we have F up is my force. His distance is 14. From the pivot point is what you're looking for. Okay. Now we have the bridge, who was 40,000 newtons. How far is he from the pivot point? Right here, right there. Halfway is 10. 10 take away 3 makes that 7. So he's 7 meters. The car is 8 meters from one end of the bridge, so this is 8. So that means he's 8. That gives us 12 left. Take away 3. So that means his distance right here should be 9. 9 plus 3 is 12. 12 plus 8 is 20. So he's 9. The car is what? 15,000 times 9. Now that should be 14 F up equals 7 times 4, 280,000, 280,000, right? Plus 9 times 15, which is 90, plus 45, which is 135,000. Okay. So now let's do some math real quick. That gives me 14 F up equals 280,000 plus 135,000, which is 415,000 divided by 14 divided by 14. So my force up should be, get out the handy dandy calculator again real quick. 4 415,000 divided by 14, and I get 2.96 times 10 to the fourth. Let's hit a pause and go confirm. Okay, I confirm that answer to be 29,600 newtons, or 2.96 kilonewtons, right? Sorry, or 29.6 kilonewtons. That is the force on the pillar. That's the force that each pillar is pushing up. Okay? How much force does each pillar exert? That's example number 3. Example number 3 for rotation equilibrium. Let me check to see if there was a part B. There is a second part. Remember, that pillar has the one that holds the car on his side. So that means this guy should support less. His force should be smaller. So we have to confirm that. So let's rework this whole problem again to make sure that that's right. Here comes the eraser. I'm going to use that eraser because I don't want to go back and, oops, sorry, that was what we call a mask, and have to go back and draw my picture again. So let's do all this. Actually, why don't we just do this? Yeah, I think we're okay. Let's clean this up for a second. Forgive me. Just for a second. I know what you're thinking. He erases a computer board just like he does in the room. But that's alright. For all you haters out there, I still love you. Okay. Here we go. Now, instead of letting this be the pivot point now, let's go back and let this side be the pivot point now. Okay? Now we're going to redraw the pillar. So I think we might just might as well just kind of redraw the whole thing again. Oh, we're okay. We can still use all the numbers. Okay, now this is the new pivot point right here. Okay, so we can erase this right there. Go back to the pen and draw our arrows. Okay, now he's the pivot point, so that means this guy here is clockwise. That means this guy right here is clockwise, and everything else is now counterclockwise. Counterclockwise. He has no torque because he has no distance. Okay, let's do some erasing a little bit more, because now we need to get these distances right here. Okay, let's get that guy. Let's get that guy. Okay, and that's our car. Now the question is now, how far is the car from this point now? This is 3, this is 8, so this is 5. This is 10. 10 take away 3, he's still 7. But this arm here is now going to be the same, what, 16. 3 in, 3 in, he's 16. So now let's do clockwise equals counterclockwise. This is the F up on the right hand side now. So that becomes F U up on the right side times his distance, that's clockwise, and then it becomes the F of the bridge times his distance plus the F of the car times his distance. And that tells you that this becomes F up, his distance was 16, the bridge was 10 and minus 3, gonna be 7, 40,000 times 7 plus the car was gonna be 15,000 times what? 5. Let me check to make sure the car mass was 15,000. The car mass was 15,000 newtons. Alright, this right here should be a what? Equal sign right there, right? Because it's an equation. 7 times that is 280,000 again. That becomes 125,000. 16F up, divide by 16, divided by 16, and let's see what we get. Should be somewhere, it better be less than 29 kilonewtons, so 29,000, because he has to support a little less because the car is parked on the right hand side, which means there's going to be more force pushing down on that side than on the other side. Making sense? I get 9,562. There's an error. Let me figure out what the error is at. I just couldn't use the calculator correctly, so I went back and pushed the buttons in correctly. I get 25,312 newtons, which is 25.31 kilonewtons, which makes sense because if you look at the problem, keep it simple for a second. Here's the bridge support, here's the bridge support. The car is parked over here. That's my car. Don't hate on my car. And that means this side here has to be greater than, let's call that F right, has to be greater than F left. Because why? The car is pushing more on that side. Example number 3, rotational equilibrium. Thanks. Love you, bless you.